All right, so as we continue, we're going to do our logic for our premix now. All right, so our premix logic, think about this. We need to have a couple different things. We need to incorporate basically our valve controls, our pump controls, our pump request, if you would, and you can incorporate your flow meter or whatever the case may be. Now, things to consider. All things to consider, we need to have we need to be waiting on the AVO3 to be open, AVO1 before AVO1 can open, and then the delivery of the actual pump and stuff like that. So what I'm aiming for is I want to be able to cut this valve on first, or request it to come on first, because this is going to be programmed out of the actual premix or the mixer routine, so that's completely separate. But I'm going to request it to come on, and then when it comes on, I'm going to allow AVO1 to cut on, and then when AVO1 cuts on, I'm going to allow it to cut on for a certain amount of time so that the pump has time to get fluid to it so it doesn't cavitate. And you want to get that pump positive pressure before you actually start, right? So you want to give it time to actually get enough fluid inside of the pump so it doesn't cavitate. And then that way product can flow through all the way through. Nice and easy, real simple. So what we're going to do is we're going to come in here and we're going to grab a couple different options. First, we need to make sure our batch is active, right? Our batch active bit. We need to have monitor our tank levels. So what we're going to do too is, well, first and foremost, let's come in here and put a no operation. No op, and then we'll put a comment above there and say this would be the actual this section controls AVO1 and pump 1 controls. Our pump 1, and then that way we have at least a description, a comment, a run comment, right? We have a run comment for what we're doing. Okay, so now we have that, and then we're going to come in here, we're going to add another rung in here. I want to make sure that the tanks are good. So what we want to do is our first tank, again, if this is AVO1, our first tank is going to be the master tank. Right, so we need to make sure our master level is good. Our master level is going to be good. So let's go into tank levels. Let's get the master level, and let's copy this. Copy this tag, and then go back up to our premix. And what we're going to do is we're going to say that is the master level okay to actually focus, right? So first, what I want to do is do a small mathematical equation. I'm going to come in here and I want to say I want to do, let's see, plus add and subtract. I'm going to take this and let's actually get the actual, well, I tell you what, let's just put to keep this as simple as possible. Let's not do that. Let's actually come in here and do this as simple as possible. Let's say that the tank level is not below a certain amount. So we'll compare it and we'll say not less than, or we'll say greater than or equal to. So we'll grab this and say tank level is greater than or equal to, and we'll come over here and say tank low level constant. And then the constant, again, is just making sure that we have a good, solid, tank level. And then we're going to use this as a real again. So this is a value. This is the data type of our real. It will be a constant, so we'll go ahead and add this in here. And then we're going to say no less than 10%. And then we're going to edit again and collect the check the constant box. And then what we're going to say is if that is okay, then we're going to say okay, we're going to turn around and say that the master tank level is okay. So we're going to say master recipe tank level okay. And then that way we can actually, let's get that level right. Okay, that's good. So we're just going to create a bool right here. We're going to use that so that we can utilize this down here. And the reason for this is to basically say, okay, well, we want to make sure the tank is within tolerance. Okay, so if the tank is within tolerance and the batch is started, then we have the ability to go ahead and start. Now, a couple things we need to know. We talked about priming, so we want to make sure we have a timer in here, and we're going to call these premix timers, right? So we'll call this premix, and then we'll do this for each valve. So we'll call this valve on delay timers. Well, we'll just say on delays. That's fine. And we'll create a couple of these because we're going to use these throughout the program. And then we'll create the variants of this. We're going to use number 1 of this one. And it's not like I have anything against 0. I just want to use the number 1 for the simple fact that this is tank 1. So it's for those that are wondering that. So we'll say we'll wait a quarter of a second, and then we're going to come in here, and then we're going to add a branch level. So in this branch level, we're going to say, okay, well, now we want to actually have a second branch level, and I'll show you the reason why. Is we're going to come in here and branch down here. We're going to use the done bit from the timer. So when the timer is done, right, we're going to request that AVO3 be turned on. And what do I mean by that? So I want to request to the other program that we haven't done yet, the other routine that we haven't done yet, the mixing routine. I'm going to request that valve AVO3. I'm going to request it to be on. Okay. So what I'm going to do is we're going to say mixer AVO3 request on. And then we're just going to click that, and then we're going to come over here and we're going to get another couple bits, and this bit right here will be the same right here. We're going to just say, is the timer done? If the timer's done, then we're going to actually say that the actual valve is on. Now in this instance, I want to actually show you too. Before we get into making the actual bit for the other AVO3, I'm going to make the bit for AVO1. Now this bit, so what we're going to do is we're going to say AVO, okay, so we're saying the timer's on, and we're going to request that the AVO3 cuts on. Now when AVO3 cuts on, the timer's already going to be done. Then when AVO3 cuts on, we're going to turn on the AVO1. Now AVO1, now take in consideration, each one of these valves will be air-driven valves. They'll be basically controlled by air, right? So they are solenoid valves hardwired to a real-world output, right? So they will be actually sending 120 volts, or it could be DC, right? It could be DC to it, either or, right? That's basically the two common things that are used inside of controls these days, and more or less aiming towards DC. A lot of people are using DC now because it's a lot safer. So this would be just a coil on a solenoid valve, right? Telling the solenoid valve to cut on, and the air would turn it on. Okay, so for that matter, what we'll do is we'll turn on, we'll go ahead and make a valve. We'll call this AVO1, and then we'll say solenoid. So in this instance, what we're going to do is we're going to actually change the this is the first time we've done this in this actual training, is we're going to change the data type, or not the data type, but the type of tag this is used. Instead of a base tag, is going to be an alias tag. Now an alias tag is basically saying that this tag that we're making is going to be related to, is going to be controlled by another alias. So another tag. In that instance, well, in the instance of this tag, I actually said that backwards. So this tag will actually be instructing the tag down here what to do, right? So we're aliasing it out, right? It could be either or. It could be it's related to the other tag. So in the instance of what we're doing, we're going to tell, when we turn this tag on, we're going to actually have the alias tag, which is going to be a real world output. And I'll show you this. We're going to go to local 4, and then we're going to call this output 1, right? And then this is basically going to say, as soon as this valve cuts on, or as soon as this tag cuts on, the flow of energy from this, as soon as this run comes true and everything is working, and the valve, or this tag changes from 0 to 1, then it's going to actually turn on this real world output, in turn turning on a solenoid valve, right? So this is that, and that shows that. So I'm going to do the same thing here as if we would have simulated the the actual AVO3 on. So AVO3, and then we're going to say solenoid, and we're going to do the alias, and then we're going to do AVO3. So this is, we're going to just basically, I don't have these real valves, I don't have everything, so I'm just going to, I do have real world outputs, and I do have everything for that. They're just connected to lights on a trainer. So in that instance, I'm going to say that my valves are my valve 1 is output 1, my valve 3 is output 3, in that case, right? So all I'm saying here is that the batch is active, the tank has fluid within tolerance to actually run a batch, then the premix valve is actually, let's actually bump this up so you can see it a little bit better. Sorry, I didn't realize that was as small as it was. But when it comes down to it, you can see that the batch was active. The master batch is okay. It has enough fluid in it to actually run a batch, has at least 10%, right? And then this is going to say that the timer is going to be on for X amount of time. It's going to be at least a quarter of a second. And then we're going to request AVO3 to turn on. Then we want to have make sure the timer is going to be on. And then as soon as AVO3 cuts on, we're going to turn on AVO1. Okay, so that's going to give it time to turn on. Now we need to add another rung. Okay, we need to add another rung right here, and this rung is going to be our batch active again. So we're just going to drag this tag down here, our batch active, so we want to make sure it's on. We're going to come down here and we're going to make sure our AVO1 is on. Then in this instance, what we're going to do is we're going to come over here and have our valve, we're going to have our actual output turn on. So we're going to have a timer on, and again, the timer on is very, very, very simple, but again, this is part of what we're doing. We're going to have another structure which has this right here, and then the request on to the actual pump. Now our pumps will be controlled from our batch control, our batch motor control routine. So we're going to do another request in that instance. Now we could actually turn the pump on directly if we had everything, like I said, if we were doing, depending upon how you do your controls. I mean, it's really, really up to the person that's programming if you want to do a request to another routine, or if you want to control everything into one routine. But in my eyes, it keeps it really, really simple of what's isolated here, what are the devices controlled in this area, if you do it this way. Now, again, and it keeps it short, sweet, to the point, right? And it doesn't actually get too long where it's hard to read. Logically, we only have so long when we're thinking about this. Some people can think really, really deep when it's logical, and some people it takes a little bit of time to actually, you may have to write stuff down, or you may have to come back a little bit later, or you may learn how to logically think over time a little bit deeper and deeper and deeper as you go. So it's easier to have a remember. I always use bookmarks and stuff like that when I'm doing that. So I'll use a bookmark if I want to come in bookmark. We'll show you how to do that later on throughout the actual course. So but again, we want to show, I'm going to have a timer. So when we have this timer, we're going to call this the premix pump prime. So we'll call this pump prime timers. And then we're going to have a couple instances of this. We actually have 2 pumps of this, so we're just going to do 3. and then we'll come over here and we'll grab an instance of this. This will be the first pump, right? And I want to give it at least 1.5 seconds to prime the pump to allow it to give it time. Now, generally speaking, you would give it maybe more than that, but for the sake of what we're doing here, I want to give it at least 1.5 seconds to keep the videos short and sweet. Keep, as we're simulating and emulating things, I want to show, have you see this process working. But generally, I'd keep this, honestly, I would keep this around like 3.5 seconds or something like that to make sure that it had a real good prime. But in this case, we'll keep it 1.5 seconds. So we'll come over here and then we'll just do this. We'll come over here and do the done. And then what we'll do is we'll call this as the pump. So pump 1 request on. And we'll make that short and sweet, really easy. And then we'll come over here and go ahead and finalize all the edits right here. So now that we have the controls for basically the first tank, we can easily see how easily all this stuff comes together. Now we're not finalized. We're just giving in like a rough estimate, or not a rough estimate, but a rough little template of how we would put things in here. But again, we're monitoring the tank. We're making sure the batch is active, and even if the batch is active, again, if we were to cut the batch active on, it's not going to cut the AVO1 on until the fact of this actually comes in and turns on the actual AVO3. Now we haven't did the programming for AVO3, so again, it's not going to do anything. But if we were to turn on AVO3, it would turn on that valve, and then it would turn on the request to pump. So you see how that works. So again, when it comes down to it, and anytime that drops, then it would drop all the controls, right? Now we're going to change the controls a little bit, but this is a rough end of how we would do things, just to get everything started, get everything working, and get everything fluently working. So again, you would come back and you would simulate, test everything afterwards, and always do your due diligence as far as going back, making sure that the system is working fluently and working the way you want it to. Right now, coming back, what we're going to do is I'm going to go ahead and do the controls for the rest of the actual tanks in here. Now again, and we'll come back in next, just kind of highlight and talk about it. As far as programming, you see exactly, I'm going to program it the exact same way. So as far as this goes, there's really no reason for you to see how I'm going to do this. But again, when it comes down to it, I can actually tie these into the actual program now. So if I wanted to come back into my HMI right here, I could come in here now and I'm going to do a visual. I'm going to do not a tag substitution, but I'm going to do a animation, and I'm going to do color. And in my 0 state, I want to keep it in the same color that it is. So I want to keep it in the same color that it is, which I believe is this, my 0 state. My on state I want to have as green. My tag I want to refresh my tag database because I added new tags just now. My tag I'm going to have as my AVO1 solenoid right here, and then I would hit apply. So now if I come in here, my AVO1 solenoid, if I hit run, it should be working. Let's see, maybe I don't have the colors right. Let me see right here if I have the colors right. I think I need to go a little bit darker shade just to make sure. I don't think it transitioned, and it may not be seeing it for some reason. Wait, let's see why it's not. Why is it not seeing it? Data server branch solenoid 1, and let's see why it's not seeing the actual color. And I don't really see that right off right now. The value is 0. This is the value of 1. This is the line, so that would work. And it may be, let's see why it's, oh, I do know why, because we did not take out the animation. So the tag substitution has this right here, and this is something I failed to actually use earlier in the actual program. We didn't actually have that, right? So I can see that from looking down here at the actual tag no longer available, and we'll see that from here, and I believe it is in color right here, and this is where it is, right? So we could have highlighted it right there, but we're going to delete it. So now that we have these in here, let's test that right now, and that works just like this. And I actually like that color a lot better. So if I were to turn the valve on, we'll now see that the color turns into a green color. So you see how that works, you see how that ties together. So we may go ahead and fix the rest of these while we're here, is going here into the animation before I make that same mistake multiple times, and go ahead and fix these on all of the valves. So let's go ahead and do that. See that right there, and we'll just delete the animation right now until these are completely done, so that we keep the same exact look and feel of everything we're doing. Okay, so do a couple more and we will be done as far as what we need to do. So, and I want to show you all this because again, it's very, very, very important to know, you know, what you're looking for and why like when you're programming, things are not going to work sometimes, and it's cool to know, okay, well, somebody's been doing it for like 18 years, still makes common mistakes just like you just seen. And they're not common mistakes because when we're programming, we're doing 18 different things at one time, and we do have things that fall through the cracks. And that's the reason why I say, and I can't stress this enough, to do your due diligence when you're programming to make sure the stuff is done right. So you see the way these look now, easily done, looks nice and good. And we're going to conclude with that. So with all that said, let's go ahead and turn our system off. We could have our batch active right now. We'll turn the system off, and we're going to come back and do some more programming. Like I said, I'm going to come down and throw the rest of this programming in here for the pre-mixing section, and then we'll come in and look at the controls a little bit and explain how it's done a little bit, and then we'll come in and start doing the other controls as far as that goes. So hopefully you got a lot out of that video. And again, I can't stress it enough to do your due diligence and testing, and we're going to do a lot of testing in this as we build it. So as we're going through it, we're going to see where we make common mistakes, when we make and we do things right, when we do things wrong, and how to fix these. So that's really, really where the education comes in, and where the knowledge pass comes in on where to troubleshoot it, where to find it, because anybody can program it. Anybody can have a bit that goes here and does this and does this and does this, but can you fix it if it doesn't? That's the key. So it's being a fluent programmer, understanding how to do things, project managing, everything works hand in hand. Full technician is everything, right? Okay, so with all that said, we'll see you guys on the next one.